we are now going to multiply radicals together. So when we add, we simply combined the like radicals, and if they were unlike, we left them separate. When we multiply, this is just like multiplying our polynomials. We simply perform the rules as we know them. So here, we're just going to distribute. And so 3 times the square root of 6 becomes 3 square root of 6, because things outside radicals only deal with things outside, and things inside only deal with things inside. Then we do the second one. We get minus 2 square root of 6 times square root of 6. And remember, whenever we combine, or whenever we multiply radicals at the same index, we simply take their insides and multiply them. And so we get 3 square roots of 6 minus 2 times the square root of 36, which is 3 square roots of 6 minus 2 times 6. And our final answer is 3 square roots of 6 minus 12. Now we don't have to reorder this like we did with polynomials. There is no set order to radicals. So we just leave it as it is in its final answer, and this is our answer. Well, let's look at another example now. Suppose we have the cube root of 4 times 5 plus the cube root of 2. And we can shortcut this a little bit. We can say cube root of 4 times 5 is 5 cube roots of 4. Cube root of 4 times cube root of 2, since the indexes match, we multiply 4 times 2 and get 8. We can't simplify the cube root of 4, so our first term stays the same. We can simplify the cube root of 8 and get 2. Well, sometimes we need to FOIL. And so what if we have 8 minus 3 square roots of 2 times 5 plus 7 square roots of 2. And so we just FOIL like we always have. First, 8 times 5 is 40. Outside, 8 times positive 7 root 2. 8 times 7 is 56 square roots of 2. Minus 3 square roots of 2 times 5 is minus 15 square roots of 2. Minus 3 square roots of 2 times 7 square roots of 2 is minus 21 square roots of 4, which simplifies to a 2. So this becomes minus 42, this last one together. So now we combine like radicals. 40 minus 42 is negative 2. 6 root 2 minus 15 root 2 is going to leave us a positive 41 root 2. And here is our answer after we've FOILed it together. Now we also have to worry about the special cases. What happens if we have 2 square roots of 3 plus the square root of 5 squared? If you remember back to our polynomials, we called this a perfect square trinomial. And a perfect square trinomial said if we had a plus b squared, we'd get a squared plus 2ab plus b squared. And if we had a minus b squared, we'd get a squared minus 2ab plus b squared. So we're going to look at our sign in the middle, and because of that one, we know we're going to use this one right here. And so we take it, and here's A, and here's B. So we're going to start with 2 square roots of 3 squared, notice the parentheses, plus 2 times 2 square roots of 3 times the square root of 5, there's our 2ab, plus the square root of 5 squared. Now we just work through our order of operations. Something to a power, well, the square applies to both, and when I square a square root, that leaves a 3. 2 squared is 4. Now we multiply. 2 times 2 is 4. Square root of 3 times square root of 5 is 4 root 15. And finally, square root of 5 squared is 5. Well, 4 times 3 is 12. And now we combine like terms. The 12 and the 5 combined is 17, plus 4 root 15, and we have our answer. We also could have FOILed this, and we would have been just fine for having done so. The last example that we want to talk about is our difference of squares. So if we have 8 minus the square root of 5 times 8 plus the square root of 5. Well, remember our difference of squares says if we have a plus b times a minus b, this will give us a squared minus b squared. So we just need to identify our a and our b, and we take our a, and we square it, and then we subtract, and we take our b, and we square it. So 8 squared is 64. Square root of 5 squared is 5, and 64 minus 5 is 59. And we get our answer. Now notice, this is important, notice that when I use the difference of squares formula, all of the square roots canceled and are now gone. We don't need to worry about them anymore. And so that's why we like our difference of squares. In fact, it's so common and so useful that we label these. So here's one of our factors and here's the other. These are called conjugates, and that's going to be really, 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 really important in just a minute.